Welcome to doassignment-ca. Here is the problem. A particle's position is defined by s equals 2 sine of pi t over 5 plus 4 in meters, where t is in seconds. Construct the s versus t, v versus t, and a versus t graphs for t ranging from 0 to 10 seconds. Now let us work through the solution step by step. The position function is s of t equals 2 sine of pi over 5 times t plus 4, measured in meters. This is a sinusoidal function with an amplitude of 2 meters, an angular frequency of pi over 5 radians per second, and a period of exactly 10 seconds, meaning one complete cycle occurs over our interval of interest. The entire wave is shifted upward by 4 meters. To sketch the ST graph, we evaluate the position at quarter-period intervals. At t equals 0 seconds, s equals 4 meters. At t equals 2.5 seconds, s reaches its maximum of 6 meters. At t equals 5 seconds, s returns to 4 meters. At t equals 7.5 seconds, s drops to its minimum of 2 meters. And at t equals 10 seconds, s returns to 4 meters. The curve is a smooth sine wave centered at 4 meters. To find velocity, we differentiate the position function with respect to time. Using the chain rule, the derivative of 2 sine of pi over 5 times t gives us 2 times cosine of pi over 5 times t, multiplied by the inner derivative pi over 5. This simplifies to v of t equals 2 pi over 5 times cosine of pi over 5 times t in meters per second. The maximum speed is 2 pi over 5, which is approximately 1.257 meters per second. Evaluating velocity at quarter-period intervals. At t equals 0, v is positive 2 pi over 5, approximately 1.257 meters per second. At t equals 2.5 seconds, v equals 0. This is where s is at its maximum. At t equals 5 seconds, v reaches its most negative value of negative 2 pi over 5. At t equals 7.5 seconds, v is 0 again, the position minimum. At t equals 10 seconds, v returns to positive 2 pi over 5. The velocity graph is a cosine wave. Acceleration is the derivative of velocity. Differentiating 2 pi over 5 times cosine of pi over 5 times t using the chain rule gives us negative 2 pi over 5 times sine of pi over 5 times t multiplied by pi over 5. This simplifies to a of t equals negative 2 pi squared over 25 times sine of pi over 5 times t in meters per second squared. The magnitude of peak acceleration is 2 pi squared over 25, which is approximately 0.79 meters per second squared. Evaluating acceleration at key times. At t equals 0, a is 0. At t equals 2.5 seconds, the position maximum, acceleration is at its most negative, approximately negative 0.790 meters per second squared, which makes sense as the restoring effect pulls the particle back. At t equals 5 seconds, a is 0. At t equals 7.5 seconds, the position minimum, a reaches positive 0.790 meters per second squared. At t equals 10 seconds, a returns to 0. The acceleration graph is an inverted sine wave 180 degrees out of phase with position. To summarize, the position function is a sine wave ranging from 2 to 6 meters. The velocity is a cosine wave, 90 degrees ahead of position, with amplitude 2 pi over 5, approximately 1.257 meters per second. The acceleration is a negative sine wave, another 90 degrees ahead of velocity or 180 degrees from position, with amplitude 2 pi squared over 25, approximately 0.790 meters per second squared. All three graphs share the same period of 10 seconds, and together describe simple harmonic motion centered at s equals 4 meters. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.